Hi, everyone. Thanks for your patience. Welcome to July 17th lecture in climate data science. We're so happy to welcome back Chad Small. This is your third time with us, I think, running this talk or something like it. It'll be a little bit different. It'll be more interactive, and we're really glad to have you here. Chad is a third year PhD student in atmospheric and climate science at the University of Washington. He's researching teleconnections between tropical phenomena and mid-altitude rainfall and flooding. He is a National Defense Science and Engineering Graduate Fellow. And Chad spends his time writing also as an environmental justice reporter and science writer. And his work has been featured in the Bulletin of Atomic Scientists, GRIST, and Next City. He is the 2025 AAAS Mass Media Fellow with Inside Climate News. He holds a BS in Environmental Engineering from Yale and a Master's in Earth and Atmospheric Sciences from the City College of New York. We're so glad you are here. Welcome back and take it away.
Thank you. So thank you guys for coming today. Hopefully this is more interactive than me talking mostly. I'm gonna give you guys kind of the run of show first, just so we kind of get an idea. Wait, there's my cursor. Um, so what we're gonna do, the broad outline, we're gonna talk a little bit about me. We're gonna talk about why science communication matters. We're going to kind of give you guys a little bit of a exercise in how to do science communication quickly, which leads to activity one. Then we're gonna talk about how we get things from like the lab or I guess like research group into the press and how we get these stories out there. Then we're gonna do another activity which will be longer about how you can take your research and like actually write it or introduce it for an audience that is not us. Then I'm gonna go and if I have time briefly into like being a media source. Some of us are gonna be like researchers, so it's good to know how to talk to the media and what things they might care about. And I'm just gonna provide some additional resources for folks who might want to know if where to go if they'd like to get more experience about science communication or just things of that nature. So with that, I'll get into a bit about me. So like Catherine said, I'm at the University of Washington right now. Going into my fourth year next year, which feels kind of strange to say that I'm like kind of more than halfway done. Uh, yeah, so I study like how tropical phenomenon impact mid-latitude rainfall extremes, kind of trying to look into how we can basically improve forecasting by looking at subseasonal prediction for synoptic events, basically. I'm originally from New York City, so kind of nice to be home for a little bit for this. But yeah, I'm also a science writer and journalist when I have time, which feels like not often as a grad student. And yeah, this summer I'm a AAAS Mass Media Fellow with Inside Climate News, which basically means like from the beginning of June to middle of August, I've been like reporting kind of full time. So which is like a very different way of operating than just doing research and things of that nature. So I'll get into more about myself, and kind of how I got from research and communications and like vice versa. So I finished college in 2016 and I like worked as an engineer in New York for about 2 years doing environmental engineering, so mostly remediation work and civil engineering, civil design work. I didn't really find that very fulfilling, so I like quit and tried to figure out what I want to do next. And then with that, I started like doing SAT tutoring, but also a little bit of writing. So I got into this environmental reporting position through Blavity, which is a magazine that does covers mostly Black culture issues. But they wanted a reporter covering environmental justice. That was a good foray into just thinking about how to do writing. And then I kind of leveraged that into thinking about things I can write more or what skills I might have that might be contributable to reporting. So I started writing Next City, and when I was writing Next City, I kind of did mostly reporting on how we could decarbonize for like climate solutions, basically, right? I was coming from engineering background, so decarbonization is very much an engineering discipline. So kind of figuring out how to do that. Then from there, I kind of found my way back to grad school. I kind of knew I wanted to do grad school, but didn't know what I wanted to do at the time. I knew atmospheric science felt interesting, so I went like basically like up the street from here to City College to my master's because I wasn't sure if I wanted to do a PhD. I really enjoyed it, so I guess now I'm here doing a PhD. But while I was there, I got to do some policy work at NOAA and on the Hill, where I was basically in Congress, learning how legislation is made that affects science agencies like NOAA, NASA, EPA, which is a good way of thinking about how our work also is meaningful for policymaking. Then I was like coming down to ending my master's, had to finish my thesis. So I started working at GRIST, which is an environmental publication, headquartered in Seattle, but kind of everywhere. I was doing data reporting, which was a good mix of reporting on things, also data analysis, which kind of fits in the wheelhouse of people in our research field mostly. And then after that, I started my PhD at UW, but also started as a fellow at the World Atomic Scientists doing climate reporting whenever I had time to do so. And then now I'm like AAA Smash Media Fellow inside Climate News this summer, which is kind of full-time reporting again, which I figure would be good to try again, having moved on, like being further through my PhD, right? Like knowing more things, I guess. So with that in mind, I'm gonna get into more of like why science communication matters, right? So what I'm gonna show you in a second is a little bit of excerpt from this paper. And the paper is trying to discuss how we can get people to find like how do we move the needle on people knowing that climate change is human caused or anthropogenic basically. So I'll give you a second to read this like paragraph here. Most people. Okay. So this paragraph here basically explains how human activities might influence climate change. The purpose of this paper was to see if we explained why things were going on, would it like help people, would it move people's opinion more? So in this paper, they actually found it did. So this like zero line here is like the baseline opinion of people, and as they show people more statements that kind of influence like the kind of let's say here's why these things happen, people started to agree more that climate change is anthropogenic, just kind of what we want. So that's good. But the bigger issue we have here is this is from Pew Center, like looking at polling, and while 90% of people think that scientists are intelligent, less than half of them think they communicate well, which is a problem given that like the previous like figure over here shows that if we communicate, it helps people's opinions change. So this is kind of a problem, as you can imagine, for how we operate going forward. So with that in mind, I'm going to get into some more interactive things for the audience and just like get us into thinking about how to do science communication quickly. So I'm gonna go through like things that help with that. So the first thing, as you can imagine, is you want to avoid jargon, right? Most people just don't understand things the way that we do, and it's important to help them like bring it down to the level they can understand, just because it's really key. The second thing is be brief. You don't want to lose people going into all the weeds and all the methods about how things work. If they want to know, they can find out more. They can ask you more, but baseline, just give them like the short, sweet um, and to that effect, I think of it like, can you clean over coffee? You know, sitting down, here's what I do for research, here's why it matters, short, sweet, done. And then one of my editors always says, explain like to me, like explain to her like she's 5, in the sense that if you explain to a child, you can then explain to anyone. Because I always think of it in the perspective that you don't, if it's very simple, scientists will understand it too, and so will your general audience. So there's no reason to make it overly complex. Obviously, at a research talk, then that's helpful because you need to be expedient, but that's not always the case. So we're gonna go into an activity. So everyone should have a little placard that says awesome or jargon on the backside of it, basically. This activity is called Pop Talks. It's from a conference I kind of came from this week called ComSciCon. Basically, the way that this works, I say one person from each group, but I'm gonna like ask people to volunteer if they want to. What you'll do is you'll have something like 30 seconds to basically go through your research and just like explain it to an audience of, I'll show you like a list of audiences, you kind of like draw at random, and it'll be like, how do you talk to them? So for example, uh, let's say I'm talking to kindergarten class. My research actually is I can say, hi, I'm Chad. I study how the Magellanic Oscillation, which is this large pressure system in the Pacific Ocean, impacts atmospheric rivers and so on and so forth. You guys would hear that, you guys would wave the jargon at my face, like wave it up and be like, Chad, that's jargon. Stop doing that, right? Or I could say to 5-year-olds, I study how places that are really warm and wet make it rain in places that are a little less warm, basically. Very to the point, very simple for 5-year-olds to get it. So what we're gonna do is we're gonna have people come up or stand up and do that. You as the audience gonna wave your placard saying awesome and jargon at folks so they know basically to either change course and bring it down or like they're doing great and keep the flow going. So here are our audiences. I have 4 of them. So you have like kindergartners, scientists in different fields. So they could be sociologists, for example. They can be like a medical doctor, so on and so forth. Somebody met at a bar or a coffee shop or high school social studies class, right? Like people of different ages, different backgrounds, different science expertise. Yeah, so I guess would anyone like to volunteer to talk about the research? Can you hear me?
Chad, I also want to note that we have about 15 online guests.
Cool.
So I'm going to invite them to unmute themselves and offer up their little pop talk if
That's
they'd like to.
that's great. So I guess I can't see. So if you see them, let me know. And
I
I'll,
will let you know.
perfect. So does anyone in the audience, either remotely or in person, want to give it a shot? Go for it. All right, cool. So I'm gonna hit this. So you have kindergartners. So stand up. So what's your name, by the way?
Hi, my name is Kate. And so the goal is to say what I work on.
Yes, but so kindergartners as like the first, yeah. So everyone's gonna have your placards ready. Kate's gonna give you like her research. You're gonna like kind of let her know if it's doing great, and feel free to go for it.
Sure. So, hi, my name is Kate. I'm a scientist and I study clouds in the sky, and specifically the stuff that the little stuff that makes up clouds, and try to see if the clouds will make rain or not.
That was great. That's awesome. Cool. Anyone else want to give it a shot?
Hi, my name is Caleb, and I just go. Let's win it.
Yeah.
Okay, so I am studying Pacific Decadal Oscillation, which is a climate indice that basically influences drought on the Pacific coast. And I'm basically trying to find correlation to see if it causes droughts in forests in California.
Sure. I hope you can listen me. My name is Luana. I
Second,
am a.
let
Can
us
you hear
just
me?
adjust. Yes, let us just adjust the sound for you. Give us one
All right.
second.
And you have group 4, so high school students. Yes.
Go for it.
So my name is Luana. I am a scientist that studies air quality and pollution through the atmosphere using sunlight. And my main goal is to expand this to high school students here in Miami.
Hello, my name is Bryson, and I'm a scientist studying meteorology. And basically, my project is about how studying how forests, specifically tropical forests, are changing under different factors such as rainfall and temperature.
I can go. Should it be for the scientist and unrelated? Okay. So if it's for someone I met at a bar, hi, I'm Aya. I'm a scientist. I work on understanding how we can use AI to understand how maybe the heat or the sun or the water can help trees start pushing out leaves in the spring, or how trees get rid of their leaves in the fall.
That was awesome. That was great. Thank you. Fantastic. So great job. Everyone did a really wonderful job. And I think you guys were much more comfortable than some of the people I've seen do this before, which is great. So that was fantastic. So, all right. So I'm going to open it up to the room. That exercise kind of touches on each 4 of these like pillars. So I'm curious, like you can popcorn, raise your hands. I guess Catherine, let me know if anyone in chat has like a thought. Just like which one of these things do you think was the hardest to encapsulate in that exercise?
I think
Probably,
avoiding jargon is the hardest for me, because we get so used to using specific words to explain our research with colleagues and when working on it, that it's hard to try to use like different words that other people will be like will understand like more easily if we're just like so in the habit of using jargon.
Absolutely. I think jargon is a really hard one because also that helps you be brief usually. And then you're like trying to fight, how do I say the thing without saying too many words? Perfect. We have someone in the room who has a go for it.
yeah, I was gonna say that like also avoiding jargon and being brief can be difficult, like not using some of these broad terms and broad definitions that of course like is easy for me to understand, but if someone never heard of it, they're not gonna it's just gonna be gibberish. So like that's pretty difficult.
One more person. Go ahead.
Yeah, I also agree. Avoiding jargon is really hard because when you're like so used to talking to different like the scientists in your field who know what you're talking about, it's kind of hard to break down very specific things. Like even if you know what it is, it's hard to explain it and be brief at the same time.
Absolutely. And to your point before the next question, I think that the acronym space we're in is really hard because everything's an acronym and people know the acronym in, and then explaining it's like 10,000 syllables. It becomes really difficult to do that quickly. Go ahead, Catherine.
Luana online says it seems to be most difficult to do this over a coffee.
Oh, interesting. Can you say more? That's an interesting response.
In my situation, it is more difficult because I'm not a meteorologist. I come from more like multidisciplinary environmental science, and I'm studying air quality. So sometimes get hard for me going through hard and complex theories and methods. So for me, it's easy to do in brief than explain in detail.
That makes sense. I think I've seen this done with people who are like nuclear physicists, which is very abstract and it's really hard. I think what they do is they try to like almost bring in a different story of that's related to the thing to help get to that point, which actually we'll do that in the next exercise about how to bring in a story to help you get to the point of explaining. But yeah, that's a great point. I think it's really hard when your work is abstract because like people don't always understand what that might be. They don't understand like the methods of what you do. Any other questions before we move on? Oh, go ahead.
I guess it didn't really come up in the exercise, but one thing I find really difficult is like moving beyond explain like I'm 5 and experts. Like when people start asking questions and trying to like continue to reply without speaking in technical terms can sometimes be very hard. And often I get really annoyed with my friends. But they're just interested. But I'm like, it's really hard to explain this to you because you don't have any technical background. So every single thing I say, I have to like.
I get that. I think the way that I've dealt with that, kind of something that I do deal with a lot because a lot of my friends aren't in the field I'm in, is I try to respond with the vocabulary they ask the question in. So I'm like, okay, you didn't take it further than this. I don't take it further than that. And like the higher the vocabulary they use in the question, I'm like, okay, I can just keep pushing further. That's kind of helped me kind of work on that. It's really hard though, because you're like, okay, what is too far? What is too deep? Things like that. Other questions here online or the thoughts? Cool. All right, perfect. So I'll move on. That was great. Thank you guys. All right, so we're gonna go into how do we get our work out there. That was kind of what I did before is very much like a one-on-one thing. It's like how do you work with people in a one-on-one setting? But I think a lot of the work we do across all spaces that like LEAP touches are very much things that impact societal implications, right? So that means it needs to get it like out there and broader, right? So I'm shows a little diagram, and we have like scientists in the media, right? We think very like broadly about media coverage, getting our work out there. A lot of scientists have a lot of thoughts about that being done properly, which is fair. I feel the same way, right? Like, so how do we get out there and have them do it properly, but then also have people who aren't us care about that work and not get bored when they read it? So I think there's a few ways you get from the scientists in the media. The first way, social media, obviously. I think Blue Sky has taken over the scientific apparatus these days, where everyone's online spreading their papers and stuff like that. And a lot of journalists actually will like kind of lurk on Blue Sky, lurk on Twitter, lurk on Instagram when people post papers and like read their like threads about like what's meaningful and like what kind of work like might be newsworthy basically. So there's that. Press releases are also interesting things. Some institutions and stuff, like faculty will work with them and say, oh, we have paper coming out in like publishing in like a week or two, right? So then they'll have a press office go to journalists and say, here's a press release about this article that might publish next week. And journalists will come and get early access to those papers to write about them thoroughly when they go live. I actually did that last week for work, actually. And the last way I think was important is like the articles themselves. A lot of reporters will just like read articles from scratch and be like, okay, what story here? Usually you need to have some kind of science background to do that efficiently. But I think for the purpose of this room, we're going to kind of work from here in thinking about how we do the next exercise and how do we get our work out there and build stories, basically. So I think if you could pass around the other sheets to people. Cool. So you're gonna get passed around some sheets, and I think people might have them online in a different format. They'll be helpful as I go through the next couple of slides and kind of help us guide and think about what we're doing next, and just like ways of thinking about things that we might want to have. There'll be resources for the future and stuff like. Right now. So I'm gonna show a journal abstract from a paper in our field, right? I'm gonna give you guys some time to read it, and I'm gonna break it down for you because I think the way that we break these down actually impacts how we think about reporting and think about stories getting out there. So it's here, but it's also on that sheet too. So you have it like there also. take like a minute or so, read it through, and I'll come back to it in a second. People turning page, I think we're good to go. All right, so I'm gonna, obviously, as we know, abstracts have structure. So I'm gonna break it down. I mean, we already know this, but I'll break it down because I think it's important for the thinking about how we build a story out of science, right? So, whoops. So every abstract has an introduction. You know, you see the beginning, gives you a little bit of context. It's like, here's a thing that we know is like, you need to know as a baseline, right? Then we show some problem. You know, every science question we answer comes from like a problem we find interesting, a problem we find meaningful. So we have some like general framing of the problem. Then we go into the quick, here's the result, here's why this matters, you know, here's what we found in the work, right? Like a quick, like short hit there. Then further down, we give a broader description of the results. Here is kind of like, you know, what we find, where, why it's meaningful, stuff like that. And then finally, we get like a context of like broader implications. Particularly now, a lot of research is very built on this idea of like, why is it meaningful? And I think not everything has to be meaningful now. A lot of research has been done 20 years, that's still worth doing. But I think now that's been kind of the framing. So these things actually impact how we think about writing a story, right? So I will go to the next slide. So I wrote a story about this study a couple of years ago, and like you guys also should also have that on that paper too. Take a look at that in the meantime. So this is like kind of what I took. This is like the first like I don't know 100 words of the article where I go into like here's why it matters, here's what's going on. But as you guys read that a little bit, I'll give you like another like minute or so to read it. I'll go into how I kind of took pieces of the abstract and pulled it into the story. Awesome. So kind of what I've done is I pulled in part of that, but not into the entire thing. So the same overview main result kind of sits like here, you know, at a certain point in the story, the like journalism is kind of weird. You kind of have to be like, here's a thing. So people know why that thing is worth reading. And then here's a further context. And this is all within the beginning of the story, but stories have structure too. So he has something called a lead. The lead is like, oh, this is nut graph. The nut graph is basically the main idea, which comes early in a story for journalism to get people to know what's going on. Everything prior to the lead, we spell lead differently in journalism because like back when they were printing things, you need to know not to print the word lead, so they spelled it wrong, so people wouldn't print it out on the actual like typeset. But anyway, lead is everything gets you to the nut graph, which everything gets you to the main idea. So you want to have something like interesting enough that people, okay, I want to hear more, and then you just hook them right into the story. So what we're gonna do today, or like for the next exercise, is kind of try a little bit of this basically. So you guys have your sheets there. So what I want you guys to do, I guess in person here, in person in Boulder, maybe like on Zoom if you can, kind of get in groups of two, possibly. What you're gonna do is I'll give you guys like maybe like 12, 15 minutes to work through this. I want you guys to think of one space of science that either of you works in that you think might be newsworthy. I want you to formulate your own story intro the same way I did. So I say 3 to 5 sentences. It could be a little bit longer, a little bit shorter. The idea is you want to like hook them in and then like get them what the main idea is and then stop there. I would suggest, yeah, some like one person in the group so it's not too overwhelming. Not that these have to go into the actual writing, but I want you guys to consider these questions as you do. Like, what do we know? You know, like why is it important? Like, what do we know? What do we don't know? What research are we doing? What results are we finding? And why do we care about these findings right now? Those are all important things for how to make science palatable in this moment. Um, yeah, and so basically I have a QR code here on the sheet. Basically what I want you guys to do is as you're done, just like put it in the form. I'm gonna like share something out to the group and kind of like workshop with the group, like what you guys thought was good, we thought was fun, we thought like kind of worked out. But yeah, I would go ahead and get started now. And on your sheets, you'll have extra QR codes because I'm sure you guys all do different science. And those QR codes have stories from other places that give examples of things in those fields that you might find interesting things to pull on and work on that might be helpful. So yeah, I would like go ahead and get started. Let's go for like 12 minutes or so, come back at like 12:45. And yeah, go for it. Yeah, I guess groups of 2 or 3, depending on how close people are. So, and I'll kind of float around the room, float around the Zoom if people have questions. So yeah, go for it. Cool. So let's come back. So what we're gonna do is I'm gonna kind of merge you guys for like 3 minutes. So you guys are like in like I think pairs. Like let's have like I think we have something like 4 or 5 pairs. Let's do 2 pairs together, 3 pairs together, and just like talk about what you guys did and like what was hard for like 3 minutes while I figure out who I'm gonna show on the screen for like the fun part basically. So go for that. All right, guys, let's bring it back. Well, let's come back. All right, so we're gonna do something more fun for a little bit. So I have two examples, interest of time, that I'm gonna like show on like PowerPoint. Basically, I'm gonna let you guys read them, take a second, and then we're gonna like talk about what we like about these. What do we think make these like would make these work? What things do we think maybe we might want to change? Just like as a group activity, basically. So here's the first one. Can you guys see this? Read this clearly? Cool. All right, take a second, read it. Everyone good? Cool. All right, so let's take like people in the room or people in the Zoom room. What do you guys like about this? What do you think would make this like a fun read or a good introduction to a story?
I found like the concept of lava clouds to be really cool. I never heard of lava clouds before, or even the planet 55 Cancri. That just makes me want to dive in some more.
Yeah. Any other thoughts? I think someone's in the Zoom, I think had a comment. Yeah, they love the connection between the water cycle and lava cycle. Yeah, exactly. I think it's a really interesting one too. Other thoughts about this one that people was interesting? So like personally, I really like the idea we don't live on a planet 10 million 10 light years away. Like a light year is kind of jargon, but I feel like a lot of people know what light year is just from like I know things like Star Wars, Star Trek, stuff like that. But like for me, I'm like, oh, I don't think of weather on different planets very often. And I think that's like really cool. Like I was like, oh, okay, like how do other planets have what's the weather look like basically? Yeah, other thoughts people might have? Go for it.
Yeah, I really like the way that it like contrasts with what we know. So to make like a comparison and kind of like visualize what it could be like on this planet.
Yeah, I think like this is really good in imagery. Imagery is great. You're like, oh, okay, I can see like what does it mean to have like a lava cloud? What does it mean like have lava rain? You know, I think those are like it makes people want to keep going. I think this is like a really good start. This is a great job. All right, I'm going to the next one. Cool. So this is the next one. Please I can read this and let me know what you guys think. Things you guys thought were fun. I mean, I can get started. I think that this one also does a good job of like describing what things look like. You know what I mean? Like people have seen like cirrus clouds before, but like the way they talk about them is cool. You know what I mean? Like wispy clouds, I think is really nice as a way to describe like it brings the person into what's going on. But other thoughts though that people might have?
I like the cotton candy imagery. I feel like actually, a lot of people don't really know that those clouds are made of ice crystals.
That's a good point. Yeah, a lot of people don't realize that those are actually ice crystal clouds, but I think that's yeah, I think cotton candy helps because it's if you think of clouds as water, cotton candy's solid. So I think it actually like helps with that imagery too. Uh, other thoughts people have? They're gone.
I think it's cool that it kind of continues into complexity. Like it starts out pretty simple and then builds with each sentence.
Yeah, something that I think people think about, people underestimate their audience a lot. I think you can like, as you write a story, make your audience smarter as along the way. Like you add more and more and help them like bring them through it, which is really nice. So I think it's always like trust your audience can stay with you. So start at the beginning and just build them up as you go through. But yeah, this is great. I mean, I have more that I have. I'll send you guys back. If you guys want like feedback on what you guys sent me like later. This is a really great. You guys did a really good job. But I want to keep us on time, so I'm going to move on into just things that might be helpful for you guys as sources, real quick. So leveraging being a source. Being a source is an interesting thing because someday we're all going to, we hopefully will be scientists. So people will be like, hey, I want to ask you about your research. Why is it meaningful for a story? And like, how do you think about how to work with journalists or media, or what have you? So I always think of interviewing the person who interviews you, which means that feel someone asks you a question to ask them like not even like why they're asking the question, but what they want to get out of that question. Because it'll help you think about what to like keep feeding them as they go through, but also it'll let you know like things like who else you're talking to, am I the person speaking to about the story? Or you can be like, hey, I think you should ask person X, Y, or Z because they might know more about this topic than I do. It's a good way of thinking about it. Also, like some stories are very short, so they might interview for story you might be like a sentence in the story. Some are really long, so you get an idea of like how much to say slash how much will be like impactful work you do. Also, like when's it being published? Sometimes you're hitting a deadline and it's being published tomorrow. And it might be good for you to know that, to know like how much to give them, such that they will know like we don't want to overwhelm them and have it be overly complex. Thank you. yeah, like you want to know what's going to be published. It helps you know what to tell them, what they should know. Um, yeah, and I think it's always a teachable moment. You can always make a source, make a journalist who like influencer, whatever, just smarter, just a better, like a better like resource. I think like a lot of reporters I speak to who've done like extreme weather climate reporting have gotten better over the years because their sources have taught them things and have made them almost half scientists along the way. So now they know what questions to ask. So I think building relationships with your sources, with your people you talk to is a really important thing to do. You just break it down to the bare bones. We went over this today, like avoid jargon when you can. Define it if you have no choice. Yeah, and just like it helps the story be accurate and stuff like that. And it builds up your like your connection, I guess, in the media space. And I think some reporters and some scientists have been talking forever, and they like kind of like have a relationship in terms of like building out different topics to speak to different parts of the science mission, I guess. Yeah, so this is just like the last slide of just things that might be helpful if you guys want to go into science like communication more broadly. A great book is The Craft of Science Writing by Siri Carpenter. She was a AAA Science Media Fellow like years ago, so I think she's a PhD also. I don't remember what field she's in, but has training as a scientist, also as a writer. A lot of different places have just like science like trainings. Metcalf Institute is in Rhode Island, University of Rhode Island. They have a science communication workshop for scientists, which is cool. AAAS also has like a science communication workshop for scientists as well. So does Compass. For grad students in the room, I just came from ComSciCon, which is a science communication conference for grad students. It was like this week in Boston. I can't really came from there to here. Great conference. I think it's a great space as a grad student in sciences to talk to people who might be able to help you become a better communicator in the long term. And the Association of Science Writers is always a good place to go. They have lots of resources for scientists and for writers. And they also connect scientists to writers, which is a way to kind of like have people you know that can communicate the work you do. That's kind of what I have like in this sense. I just want to acknowledge people who've helped me like I'm part of two research groups at school, Sui Chen's group and Abby Swan's group, which has been really helpful for me as a scientist. And I like was a TA with Dr. Kat Hybers, who was a great science communicator herself and kind of helped me figure out how to do this work more broadly. And then also just like Bulletin's been a great resource as a writer. So has SJN, which is a great space for reporting. The Climate Coalition has been a great space as like a growing and thinking about writing as it impacts the environment, impacts the economy. Brew Project is a consortium of reporters, mostly of color, who do reporting on the environment and climate. I'm part of that consortium too. And it's AAAS, kind of like a media fellow right now. It's a good space to like kind of seed scientists into the reporting space. So that's kind of what I have, and I think we're just at time. If you have any questions, let me know. If you want to do feedback, there's a QR code for that also. But yeah, questions, thoughts.
Do you feel like you would approach, if you look back at stories you wrote maybe like before you went to grad school, do you look back and say like, is your perspective really shifted? You would have done something differently, or you're still kind of like, it's a kind of a pretty separate skill to be doing science journalism?
I think I do, but not because I'm further along grad school. I think I just was also a baby reporter then too. So like I just happened to be, I feel like I just knew less things about reporting then also. I think if I could go back, I'd probably just interview more people for every story. I think now I like aim for like at least three or four. Just because I think it makes a story just bigger. And I don't use everything I interview for or look up. But I think like, yeah, I think that's the biggest thing. Other thing too is I just like am a better skilled data scientist now by virtue of being a grad student. So I think I would probably look at data more thoroughly than if I had the skills that I have now. Those are the two big things.